Alright, the distance formula. What do we use the distance formula for? We use the distance formula to find the length of segments in the coordinate plane. We found lengths of segments for a while now, but not in the coordinate plane, or not diagonal ones. If they're horizontal or vertical, we can do it much simpler, but if it's any segment in the coordinate plane, we need a formula. So here's the start of it, square root, and then I start building it inside the square root a way that makes me remember it because I relate it to other things. The plus sign and the 2 squareds come because the distance formula is related to the Pythagorean theorem. Right, I'll put something up extra about that in a little bit. I talked about it in class. Eventually I'll get to a supplementary video because it's kind of important stuff. And then the minus signs, that's because it's related to slope. So if you remember that slope is y2 minus y1 over x sub 2 over x sub 1, you remember that it has the 2 minuses. It has the same parts as slope, the y2 minus y sub 1 and x sub 2 minus x sub 1. They're just inside this radical. So let's do a problem. Find the length of segment GH. So here's a point G, here's point H. Got 2 ordered pairs. And so then we're going to write the formula, and I like to write it out with the variables to start with just because that helps me memorize it. And then I'm going to start substituting things. Again, empty one, build it piece by piece, then worry about what pertains to this problem. My 2x values are 1 and negative 3. My 2y values are negative 4 and 2. Then I'm going to start simplifying. So 1 minus negative 3 is the same as 1 plus positive 3. Cross the line, change the sign. Get 4 squared plus negative 4 minus 2 is the same as negative 4 plus negative 2. So I get negative 6 squared. Square those numbers. We get 16 plus 36 under the radical sign. And so we get square root of 52. Now from that point, we have a few choices. You might be asked to write your answer in one of the following ways. Either you're going to be asked to simplify it. That's the one where we start with the factor tree. 52, we can break down 4 times 13, 13 times 4. We know we can't go any further with 13 because it's a prime number, but 4 is 2 times 2, and now all of those are prime numbers, so we can write them under the radical sign there. We're looking for pairs. If I have a pair inside, one comes outside, so then we have 2 times the square root of 13, 2 radical 13. That's the simplified answer, or I might ask you to estimate. So to estimate, we want to think about the square root of 52. What's it closest to? What perfect square is it closest to? It's close to 49. So the square root of 49 is 7, so we know it's bigger than that. The square root of 64 is 8, so we know it's smaller than that. We really, if you want to get technical, we got to figure out, which is it closer to. It's much closer to the 49, so it's probably, closer to 7 than 8. I'm fine if you just leave it 7 point squiggle, but if you had to choose one of those, which would you choose? 7.2, because it's closer to 7 than 8. Barking dog. Okay. He was trying to tell me the timer was going off. Dinner is ready. One more problem. Find the length of segment AB. So I could write that 2 different ways. I could write it out in words, find the length, the word length, and then segment AB with the flat hat to represent that it's a segment. Or I can say find AB without the hat, that means it's the length. So there's my points. I'm going to put them into the formula. And step by step, the 2x terms, the 2y terms, do the math, and I get square root of 89. So again, I have two different options. Estimate. Square root of 81 is 9. Square root of 100 is 10. This time it's pretty close to the center. 8 units that way, 11 units that way, so it's a little closer to 9, but not much. I'd probably say it's about 9.5. I don't know, I didn't look it up, but pretty close to the center. 9 point something. And then to simplify, you can't simplify it. You're done. So, there you go.